Hey guys, K85 here, and today I'm going to go over the concept of asymptotes with you guys. I hope you enjoyed the video. Please do consider subscribing to my channel. I would really appreciate it. And with that done, let's get into the video. So, we're going over asymptotes today, and we need to go and define the rules of the road, shall we? So, let's write down the base form of an asymptote, y equals to 1 over x. So, if we substitute x as 0, we run into a problem. Sorry, that's not an equal sign. If we substitute x as 0, we run into a problem. Thing is, it's a null set. It won't work. So, we have to avoid running into 0. So we have to make sure that x never hits 0. Now we've laid down the rules of the road. Let's talk about the, let's say, makeup of an asymptote, like the pure concept. So an asymptote is a graph that does not touch an axis. Let's take the green asymptote. It has an equation of y. Its equation is y equals to 1 over x. I graphed it like that. And it has asymptotes with the x-axis, you can see it here in my pen, and the y-axis, you can see my pen go down. And it never touches those axes, even though it looks like it touches those axes. And we can also do this with some practice. Let's take the blue blue asymptote real quick. So its equation is y equals to 1 over x plus 1. Okay, with this asymptote, it's shifted up 1. And you might be saying, oh, K85, it intersects the x-axis. It violates the rule that we just set out. Actually, the thing is, the asymptotes are usually the axes, x-axis and y-axis, but sometimes it has other asymptotes, like it has, if we substitute 1, just to prove that it's mathematically legal, it goes to 1 over 1, and that's legal. So this point is okay, and the asymptote is still with the y-axis, but it's with the x-axis point that will get it to 0. So this is the, if we were to graph the x-axis, it would be x equals to 0, and that would be the line. And if we were to graph the y-axis asymptote at 1, because that's the other asymptote, it would be the asymptote that looks like it's at the x-axis. It's the horizontal asymptote. Now let's take up the case of the red asymptote. Its equation is y equals to 1 over x plus 1. So if we solve for, let's say x plus 1 equals to 0, and if we solve, we get x equals to -1, so if we substitute -1, the equation cannot work. So actually, the asymptote for this asymptote is at -1, and that would be a line like that on the x-axis. And y cannot be 0 because then it becomes true, and it has an asymptote like that. Where my pen was. So we can do that. And I haven't touched up on the shifts concept. We did the blue and red parabolas, but if you notice, the keen-eyed viewers, the blue asymptote, it shifts, I meant to say asymptotes earlier. The blue asymptote shifts up 1 like that. And the red asymptote shifts to the left, -1. That's very similar to another graph, parabolas. let's do the parabola equivalent. X squared plus 1 for the blue asymptote, and x plus 1 whole squared for the red one. We can see that shifts are like going through all these graphs. It's like they're all cousins. Like it's the same thing for parabolas, cubic functions, many other functions. They all have it like that. And asymptotes are the same also. So that's all. We covered the concepts of shifts today. We also covered the concept of asymptotes. We covered the concept of why x cannot be 0. We covered the concept of graphing it in perspective of the asymptotes. And I hope you guys learned about asymptotes today. Thank you for watching my video. And I'll get out with more videos soon. And thank you for watching. K285 out. Bye-bye.